Hello, my name is Mr. Ashbury and this is a MadAsMaths synoptics paper. It's the first paper out of a whopping 26. They're 3 hours long and they are super duper tricky. So give this paper a try. I'll leave the link in the description and then watch the video to see my solutions. And if you want to see more of these papers, then just like the video and subscribe to the channel. If this video gets 30 likes, I'll do the next one. I'll do paper B. Fantastic. Right, let's do it. Question 1, we've got two coordinates and it says show the perpendicular bisector is given as this. So the first thing we want to do is work out the midpoint between the two. And we take the two x values and add them together and then half it. Take the two y values, add those together and half. And this gives us 3 and this gives us 8. Now we're going to need to work out the gradient of the line. And the gradient is equal to the change in the y, so 11 to 5, so 11 minus 5, over the change in the x, so 7 minus 1. This is 6 over 8. Great, so now I can work out the perpendicular gradient, because this is just the negative reciprocal of the gradient between the two of them. So this gradient can simplify down to 3 over 4. The negative reciprocal will be minus 4 over 3. Okay, so all that's left to do now is to do my y minus y1 equals mx minus x1, my equation of a straight line. So I know one point on this new line. It's the midpoint of A and B because it's the bisector. So I can put 8 in here. The new gradient is perpendicular to the old one, so that's the new gradient, and the corresponding x-coordinate is 3. Great thing about this formula is I can just multiply both sides by 3. Whoops, this gives me 3y minus 24, and then I can just multiply this bracket out by minus 4. So that gives me minus 4x, and minus make a plus, so 12. And then all I need to do is bring the x over to this side, keep the 3y on this side, and then move the 12 over to that side to get 36. Okay, next we're told that the line crosses at P and Q, the coordinate axis. Find the area of OPQ. Okay, so let's imagine that we have a coordinate axis, something like this. We know that it crosses the y-axis when x equals 0. So when x equals 0, we get 3y equals 36, which gives me that y is equal to 12. So it crosses here at 12. And next, we can work out where it crosses the x-axis by setting y equal to 0, and then subbing that into the equation would give me 4x equals 36. So x is equal to 9. So we've got 9 over here. And then if I were to draw the line, it would look like this. So the triangle area would be a 1/2 times base times height, which is the same as 54. Question number 2, we've got a cubic and it's defined in terms of constant k, and it says given that x minus k is a factor, then determine the values of k. So if x minus k is a factor, then that tells us that f of, whoops, wrong colour, f of k is equal to 0. So subbing in k is going to give me k cubed plus k squared minus k plus k, and that's going to equal 0. So I'm going to get that k cubed plus k squared is equal to 0. I can take out a factor. It's always important to factorize if you can. And this gives me this. So therefore my solutions are either k squared equals 0 or k equals -1. And so therefore the two solutions are that k equals 0 or k equals -1. Question 3. Simplify fully each of the following expressions, writing your final answer in terms of root 2. So root 98 is the same as root 49 times root 2. And then we're adding on a root 2 afterwards. This is for part I. And root 49 is 2. So we've got, root 49 is 7. So we've got 7 root 2 plus 1 root 2, and that's a total of 8 root 2. Next one, looks like we're going to have to expand those brackets. So 2 root 2, and then root 2 times root 2 is 2, times -3 is -6. That's just 6. And that's 3 times -3 is -9, so -9 root 2. So simplifying this, the -6 and the +6 cancels, and we've got 2 lots of root 2 minus 9 lots, which gives me -7 lots of root 2. Great. Part B. Solve the equation. Well, I can see here that 3 is the base which we need to use. So 27 is the same as 3 to the 3. This bottom one is already in base 3. And we have here a 3 to the 1 multiplied by root 3, which is the same as 3 to the half. Okay, do some simplifying. We've got this bracket rule here, which means we multiply the two powers, so we get 3 to the 3t. And over this side, we're going to get 3 to the 1.5, or 3 over 2. Okay, and here we're going to be dividing 3's, which means we subtract the powers. So I'm going to end up with 3 to the 3t minus t minus 1. And that's equal to 3 to the 3 over 2. And that tells me now that the two powers must be the same because the bases are the same on both sides. So I get 3t minus t, which is 2t, and then a minus 1 is a +1, and that must equal 3 over 2. So therefore 2t is equal to a half, so therefore t is equal to a quarter. Okay, tricky inequalities question. First off, I don't like having the negative sign there, so I'm going to move it to that side. So I'm going to have 12 is greater than or equal to 7 plus 2 lots of modulus of 2x minus 3. Then going to minus 5 to both sides and divide both sides by 2. And then I'm just going to write it the other way around. So 2x minus 3 needs to be less than or equal to 5 over 2. Next what I'm going to do is I'm going to sketch. I'm going to go to graph, and I'm going to so I've put in modulus of 2x minus 3 and 5 over 2. And I press draw. Great, and we want where the modulus is less than the line, so we want the bit in between. So I'm just going to draw that over here. So we have the modulus coming down like this, and we have the line coming across like that. and we're going to want the bit there. So we need to find out what these intersection points are. So we do that by solving the equation in two ways. We solve it when the modulus gives us a positive. In fact, we just write equals now, we just want to work out what the points are. And then we swap over the signs inside the modulus and solve it that way. So this way will give me 2x is equal to, add on 3 is the same as 11 over 2, which means that x is equal to 11 over 4. 11 over 4. And for this one, we can end up with 2x is equal to a half, so x is equal to 1/4. Again, we're looking at the, this will be a quarter here, and this will be 11 over 4. We want the region in between them, so our final answer will be an inequality given like such. Question 5, we've got a curve and we've got a straight line. It says, it gives you the curve, gives you the straight line. It says the curve meets the point, the straight line at the points A and B, and the region R is shaded, bounded by the curve, and then just find the region basically. Okay. So first things first, we need to find the points A and B, and they happen when they intersect. So we're going to do a simultaneous equation whereby the curve is equal to the straight line. Let's move everything over to the right hand side. This is going to give us a positive x squared. We're going to get minus x, and we're going to get minus 6. And this will give me x minus 3, x plus 2. So I'll have x is equal to 3 and x is equal to minus 2. So that's minus 2 and that's 3. Okay, now what we'll need to do is integrate, and I want to integrate between 3 and 0, and I want to integrate the curve, but I'll need to subtract the line, and that will give me the region. So I need to integrate between 3 and 0, the curve, minus the line with respect to x. Okay, so let's simplify this before we integrate. This is going to give us 6 and x and minus x squared. And then when I integrate this, it's going to give me 6x plus up the power to 2, but then divide by the new power to get half, up the power to 3, and then divide by the new power to get a third. Between 3 and 0. Okay, substituting in 3 is going to give me 18. It's going to give me 9 over 2. And it's going to give me 27 divided by 3, which is 9, so minus 9. And then when I sub in 0, I'm just going to get 0. So this is going to be 9 plus 9 over 2 is 13.5, as required. Okay, question 6, we've got a trapezium, and it tells you what the sides are, and it tells you what the area is, so it says find the length BC. Okay, well, let's use the trapezium formula for area. And that is that the area, which is going to be 16, is equal to 1/2 of the two parallel sides added together, and those two are these two, so add those two together is going to give me 3x plus 2, multiplied by the height of the trapezium, which is 2x. Okay, the 2 and the half will cancel. So this leaves me with 16 is equal to 3x squared plus 2x. Setting this equal to 0, it gives me 3x squared plus 2x minus 16. And then we can solve that. I'm going to be a bit lazy and just use my calculator. Degree 2, 3, 2 and minus 16. And we get 2 and something else negative, but it must be the positive one. So x equals 2, because we are looking at length here. So let's go back to the diagram. And let's draw a line down here. We know x is 2, so this is 2x, so that's 4. We know that the gap down the bottom here is going to be 2x plus 1 minus x plus 1. So that's just x, which is just 2. So therefore we've got a right angled triangle. The hypotenuse is going to be the root of 4 squared plus 2 squared. So the height, or not the height, sorry, BC is equal to the square root of 4 squared plus 2 squared, which is equal to the square root of 16 plus 4 is 20. So that's equal to 2 root 5. Okay, next question, we've got a binomial expansion. So the first thing I'm going to do is write it as a bracket. So we've got 1 plus 1/8 x, and the square root means the power of a half. So we're going to use the formula, which is given in your formula booklet. It starts off with, and actually we can use it directly because this is 1, which is perfect. We don't need to take out a factor. So we're going to get 1 plus nx, which is going to be a half multiplied by the x term, which is an 1/8 x. And then we're going to get plus n minus 1, and then x will be squared, and that will be over 2 factorial. Okay, so this is 1 plus, that will be 1/16 x. Here we will have 2 times 2 is 4. Let's just do this on the calculator, I don't want to make a mistake. We're going to have, on the bottom, we're going to have 2 times 2, and we're going to get an 8 times an 8 as well. And then we're also going to have on the bottom a 2. So it's going to be negative minus 1 over 512 x squared. Great, and it says up to including the x to the power 2 term. Okay, next, by substituting x equals 1 into the expansion, show that root 2 is equal to this, or this. That's interesting. Okay, well, when I sub in 1 on the right hand side, I'm going to get 1 plus 1/8 to the power of a half. And if I sub it in on this side, I'm going to get 1 plus 1/16 minus 1 over 512. Okay, let's simplify this, because that's going to be 9 over 8 square rooted. And on this side, we are going to have, let's get out our calculator again. Uh, 1 plus 1/16 minus 1 over 512. That's going to give us 543 over 512. And this gives me 3 over 2 root 2 is roughly the same as 543 over 512. We can then divide both sides by 3 over 2. So divide the answer by 3 over 2, and that gives me that 1 over root 2 is equal to 181 over 5 over 256. Okay, now there's two ways of getting this into just root 2. The first way is that we could literally just flip over that fraction, and that'll give me root 2 is equal to flip over this fraction, or the second way would be to times that fraction top and bottom by root 2, which will give me root 2 over, and then the bottom, root 2 times root 2 is just 2. And timesing it top and bottom by root 2 is just the same as timesing it by 1, so there's no need to change the other side. But then multiplied through by 2 gives you root 2 is equal to 181 over 128. And I believe these are the two that we are looking for. Okay, we've got the position vectors of 3 ABC, and it says that we also have D as a parallelogram. Determine the position vector of D. Okay. So if it's tricky, let's just draw a picky. And let's just draw a random parallelogram. And it says the parallelogram is labelled ABCD. So we can just draw it like this. So A, B, C, and D. So just as long as it goes around in that order, then we're good. And let's imagine that we have an origin over here. And what we need is we need the position vector of OD. That's what we're looking for. Okay, so how are we going to find O to D? Well, one thing we could do is we could go O to A, and then what we can do is we can do the same B to C, because B to C will be the same as A to D. So we're going to go from O to A and then A to D, but that's the same as O to A plus B to C. And how do we go from B to C? Well, B to C is the same as O to C minus O to B. So this is the calculation you need to do, and just to clarify why that's the case, B to C would be the same as going from B to O and then O to C, which is the same as minus OB and plus OC. Okay, great. So let's then put these in columns. So first off we have OA, which is 2, 3 and minus 1. We have OC, which is, careful, there's no I, so the zero's at the top, 7 minus 4. And then minus OB, which is 5 minus 3 and 4. So top line we've got 2 minus 5, which is minus 3. Then we've got 10 plus 3, which is 13. And then we have minus 9 on the bottom. Okay, next part of the question says determine the distance AC. Okay, so let's get rid of some of these. A to C is like this, and the way we can do that is we can go from there to there and then from there to there. So I can write that A to C is equal to O to C minus O to A. So let's put this in column form. We know that C is 0, 7, minus 4. And we know that A is 2, 3, minus 1. So this is going to give me minus 2. It's going to give me 4. And we're going to get minus 3. And the distance from A to C is the magnitude, which we do by just squaring the components. So minus 2 squared is just the same as 2 squared, 4 squared, and minus 3 squared is just the same as 3 squared. So this is going to be 29. Okay, next we're asked to work out the angle at ABC. So this angle in here. So we're going to use the cosine rule. So we're going to need to know the distance of AB, and we're going to need to know the distance of BC. Okay, let's start with AB. Do we have that yet? No, I don't think we do. So we're just going to do OB minus OA, which is equal to 5 minus 3, 4, minus 2, 3, minus 1. Which is 3 minus 6 and 5. So therefore the modulus is equal to the square root of 3 squared plus 6 squared plus 5 squared, and that's equal to the square root of 70. Okay, and BC we nearly calculated because it was this, wasn't it? Yeah, it was that. So let's just say that BC, the modulus of BC is equal to, top will be 5, so 5 squared. This will be 10, so plus 10 squared. And this will be minus 8, so just 8 squared. So that is going to be the square root of 189. Okay, right, finishing off, we just need to work out this angle in here. Let's call it theta. So we're going to use the cosine rule. And we will, I'll just grab some more space here. So that was AC. So the cosine rule, cosine theta will equal, it's going to be root 70 squared plus root 189 squared minus the angle opposite, which, the side opposite, which was 29, or root 29, AC. Yep, all over 2 lots of root 70 and root 189. Sorry, that should be a root under there. Okay, and then to cut a long story short, that is going to give me an answer of 1.1 degree. Okay, question number 9, it says that we need to work out A, B and C. So first thing I'd do here would be just to multiply both sides by x minus 1. So we get x squared plus 3 is equivalent to x minus 1 plus b x minus 1 plus c. Then I would substitute in x minus 1. So let x equal, plus 1. If x is plus 1, then we're going to get 4 on this side. Cancel, cancel, and that's going to give me c. Then I'm going to let x equal 0. And if that's the case, I'm going to get 3 on this side. This bracket here will cancel because there's just a times by x, which will be 0. This will give me minus b. And then plus c, which we know is 4. So this tells me that b is equal to 1. And then finally I would just sub in any other number. So let's just go x equal to 2. This will give me 4 plus 3, which is 7. And then we'll get 2a times 1, so that's just 2a. We'll get 2 minus 1 is 1, times by b is just 1, and then plus 4 is c. And this will give me that a is equal to 1. Alternatively, you could just divide x squared plus 3 by x minus 1 using long division. Okay, hence or otherwise evaluate the integral between 4 and 2. Right, we can do that. So we're integrating between 4 and 2, and we have ax, which is 1x, plus b, which is 1, plus, and then we have 4 over x minus 1 with respect to x. Okay, we're going to integrate each of these, so that's going to give me a half x squared, that's going to give me plus x, and this one, if I'm integrating 4 over x minus 1, I'll take a 4 outside of the integral, and then because the derivative of the denominator is the numerator, that's going to give me a ln of the numerator, so this becomes 4 ln of x minus 1. And all that is between 4 and 2, and we've got to give the answer in terms of natural logarithms. Okay, right, it shouldn't be a problem. So let's sub in 4. We get 16 over 2, which is 8, plus 4, and then we are going to get 4 lots of ln 3. And then we're going to be minusing the other side, which is going to be 2 squared over 2 is 2, plus 2. And then we'll be plussing 4 ln of 1. Whoops, just kind of run out of space there. But ln of 1 is 0, so that can just disappear. Perfect. So we're going to get, in terms of the numbers, we're going to get 12 minus 4, so that's 8. And then we're going to get plus 4 ln 3. And I think that is done. Okay, next question. We've got cos 2x here. And it's important to know the double angle formulas for cos 2x. It's cos squared x minus sine squared x, which could then be transformed into 2 cos squared x minus 1, or 1 minus 2 sine squared x. Okay, so it's not always obvious which one to use, but this one on the bottom here, there's a plus 1. So I'm going to use this one because that's going to give me a -1 to cancel with that +1. And the top one, I'm not really sure which one to use, so if in doubt, just use the original one. Okay, so that's going to give me cos squared x minus sine squared x over, we're going to get 2 cos squared, and again the -1 and the +1 is going to cancel out. So that's just going to be 2 cos squared x, and that's equal to 1 minus 2 tan x. Okay, so we want our trig equation to be in terms of just one trig function, and we have a tan here, so it would be great if I can convert this into a tan somehow, and I've already can see that I've got a sine over a cos, so that could be quite helpful. Okay, so let's divide each term by 2 cos squared. So cos squared divided by 2 cos squared is just a half. Minus sine squared divided by 2 cos squared is minus 1/2 tan squared. And this is very nice now because now we have it just in terms of one trig function. I'm going to multiply both sides by 2. And I'm going to bring everything over to the right side. That's going to give me a positive tan squared x. And then that's going to give me +1. Okay, this cannot be, this can't be factorized. So instead, what I'm going to do is I'm going to just cheat and use my calculator, basically. So menu, equation, polynomial, degree 2, we've got a 1x squared, we've got a minus 4x, and we've got a +1. And we're going to get 2 plus root 3, so we're going to get a tan x is equal to a 2 plus root 3, and we're also going to get tan x is equal to 2 minus root 3. Okay, great. Then I'm going to go to my calculator and I'm going to press, I'm going to make sure that I'm in the correct mode first. I need to be in radian mode because you can see the range, oops, is in radians. And then I'm going to do tan to the -1 of 2 plus root 3, and that's going to give me nice 5 over 12 pi. And then the second solution for tan I can achieve by adding on pi, which is going to give me 17 over 12 pi. Okay, and if I were to add 360 or 2 pi to any of those two, it's going to push me over the range, so I know I'm good. That's my final answer for those. And then over here, I just need to go back into my calculator, and I need to change this to a minus, and that's going to give me a 12 pi, and then when I add on pi, it's going to give me 13 over 12 pi. And once again, if I add 2 pi to either of those, it's going to push me over, so I know that I've got all my solutions now. Question 11, we've got a cylinder, which is open at one of its circular ends, and it's got a capacity of 1500. Show that the surface area of A of the container is given by that. Okay. So first things first, we are actually going to look for the volume, because the volume is of course pi r squared times height, and we're also told that it's equal to 1500. And why do we do that? Well, this is then going to be able to give us an expression for the height, which we are going to use when we work out the surface area, because the surface area is not in terms of the height. Okay, how do I work out the surface area of a cylinder? Well, it's open at one of its circular ends. Okay, right, yeah, so it's open, so which means it's only got one circle. So pi r squared, because look, this is not needed. There's no metal needed to do the lid. It's just the base that's needed, and the curved surface area. And the curved surface area is the circumference multiplied by the height, and that would give me a kind of a rectangle when I unravel the curved part. So it would be the height times by the circumference. So that is 2 pi r multiplied by h, and h we found is this. So therefore the surface area is pi r squared plus 2 times 1500 is 3000. The pi and the divide by pi cancel. The r and the divide by r leaves me with 1 over r. And that's what is required. Determine the value of r for which a is a stationary value. Okay, so that means that we need to just do the derivative of a with respect to r. So differentiating this is going to give me 2 pi r, and this is the same as 3000 r to the minus 1, so it becomes minus 3000 r to the minus 2 when I differentiate it. And I want that to equal 0 because it's a stationary point. I'm going to multiply everything by r squared, and that will get rid of the r to the minus 2. I'm then going to move everything over to the other side, so I'm going to get 3000 divided by 2 pi. So r is equal to the cube root of 3000 over 2 pi. So that's the calculator jobby. The square root, oh no, sorry, the cube root. Oh no, come on. Right, got there in the end. 5.81. Okay, next part. Show that the value of r found gives a minimum value. Well, we need to do the second derivative test for that. So let's differentiate again, which is going to give me 2 pi. And we're going to get positive 6000 r to the minus 3. Okay, and so when r is equal to 7.816, we can tell here that the second derivative will be greater than 0. And thus we have a minimum value. Because when you sub in r is equal to 7.8, that's definitely going to be greater than 0, because we've got 2 positives there. So thus it makes it a minimum value. And then finally, calculate the minimum surface area. So I just need to take the area formula and sub in the value for r, which gives the minimum. So that's going to give me a is equal to pi 7.816 squared plus 3000 over 7.816. And I've put that in my calculator, and that's given me a value of 576. Great. Okay, question 12. Find the range of f. Everyone's worst question, this. What we can do is, first off, we can sketch it. That's really helpful. So if you go to menu graph, and then if you delete that one and delete that one, and then you just go x squared minus 2x minus 3, and you draw it. You can then go v window, and you can go x between 0 and 5, and again draw it. And then you can see where it hits the y-intercept. That's at minus 3. You can also see where the minimum point is, which is at y is minus 4, so that's the smallest it could possibly be. And we can see what the highest it will be by going to, again, gsolve, going to calculate the y value, and that is when the x is equal to 5, so the y is equal to 12. So all from my calculator there, I can see that the range is between minus 4 f of x and 12. Okay, great. Part B, determine the value of a if g of f of 1 is equal to 6. Okay, first off, let's find f of 1. So put 1 into f. That gives me 1 minus 2 minus 3, which is the same as minus 4. And then let's put that into g and set it equal to 6. So putting minus 4 in is going to give me minus 4 squared is 16, so 16a plus 2, and we're told that's equal to 6. So 16a is equal to 4. So a is equal to 4 over 16, which is 1/4. Okay, question 13. You've got two curves and they intersect at the point P. Find the coordinates of P. Right, straightforward. Let's do 2e to the minus x must equal e to the x minus 1. This is a hidden quadratic, and in order to make it more clear, I'm going to multiply both sides by e to the x. So that will give me 2. That will cancel with e to the minus x. I'm going to get e to the x times e to the x, which is e to the 2x, and I'm going to get minus e to the x. I'm going to bring it all over to one side. And then what I'm going to do is I'm going to let y equal e to the x. So therefore y squared is equal to e to the x times e to the x, which is e to the 2x. And then I'm going to replace those. So I'm going to get 0 is equal to e to the 2x, sorry, y squared now after the substitution, minus y minus 2. This can be factorised to minus 2 plus 1. So therefore y could equal 2 or y could equal minus 1. Y we know is e to the x, so e to the x can equal 2 or e to the x can equal minus 1. But it can't equal minus 1 because we can't raise something to the power and get a negative. Sorry, we can't raise e to the power to get a negative. Solving this equation, take lns of both sides, gives me x is equal to ln 2. So that's the x coordinate, but I also need the y coordinate, so I'm going to sub it back into one of my originals. Let's take the one on the right. So let's say that y is equal to e to the x minus 1. So y is equal to e to the ln 2 minus 1. E to the ln 2 is just 2. So therefore y is equal to 1. So my final answer is a coordinate p is equal to ln 2, 1. Okay, question 14, we've got a function and then it's obtained by translating the graph by a 1 unit in the positive x direction. So that's the same as f of x minus 1. That will move it one direction in the right. So let's work out what that is. So f of x minus 1 means we replace all the x's with x minus 1's. So it's 4 lots of x minus 1. And then x minus 1 minus 1 is the same as x minus 2. Okay, next we're going to take this function and then we are going to horizontally stretch it by a scale factor of 2 over 3. And if you're stretching in the horizontal direction, the scale factor is actually 1 over whatever you multiply by. So therefore, whatever I multiply by needs to be 1 over this. So it's 3 over 2. So g of x is going to equal, multiplying inside the bracket by 3 over 2, f of 3 over 2 of x minus 1. So I need to multiply all of these x's by 3 over 2. So it becomes 3 over 2x minus 1 and 3 over 2x minus 2. Okay, and now we can simplify this. I can distribute this for 2 in there and 2 in there, which will give me 3x minus 1 and 3x, 3x minus 2 and 3x minus 4. I can expand these brackets, I'll get 9x squared, get minus 12x and minus 6x, so minus 18x, and I'll get minus 2 times minus 4, which is plus 8. Okay, next question. It says the graph of f of x is obtained by translating the graph of h of x by 1 unit in the positive x direction, followed by a vertical stretch by scale factor of 2. Determine the simplified equation for h. Okay, so let's start with f of x and then work backwards. So first off, h of x was shifted, and then finally it was vertically stretched. So let's work backwards, and then let's start by vertically stretching it by a scale factor of 1/2. So that will be taking f of x. We need to do f of we need to do 1/2 of f of x is what we need to do. And that is 1/2 of 4x, x minus 1, which is just going to give me 2x, x minus 1. Okay, so we've reversed this process, and now we need to reverse this process, which is by 1 unit in the positive x direction. So we need to move it 1 unit in the negative x direction, so that's to the left, and we do that by doing x plus 1 inside the brackets. So we need to do x plus 1 inside the brackets. So we replace x with x plus 1, and x turns into x plus 1, then minus 1 just becomes x. So multiplying out these brackets will give me 2x squared plus 2x. Okay, we have a circle, find the radius and the centre, so that's really straightforward. Not going to bore you too much with this. Complete the square. That's going to give you minus 36 out of that one. And then complete the square again. Minus 1, that's going to give you minus 1 out of that one. And then plus 33 equals 0. So we'll get x minus 6 squared plus y minus 1 squared. And that's going to give you minus 4, so it equals 4. So therefore we get the centre is at 6, 1, and the radius is 2. Okay, the straight line with equation y equals x minus 3 intersects the circle at the points P and Q, dividing the circle into 2 segments. Determine the coordinates of P and Q. Okay, well we need to do a simultaneous equation here. And we're going to substitute the line into the circle. I always find it best to actually do it into the original equation, because you may have made a mistake when working out this one. So this is going to give me x squared, y squared will be x minus 3 squared, minus 12x, minus 2 lots of x minus 3, plus 33 equals 0. Okay, expanding out, it's going to give me x squared plus another x squared minus 6x plus 9, minus 12x minus 2x plus 6 plus 33 equals 0. And then let's collect up. So we're going to get 2x squared. We're going to have minus 20x. And we're going to have 9 plus 6 is 15 plus 33 is 48 equals 0. Divide through by 2. Factorize. Oh, hold up. Nope, 6 and 4. So we get x equals 6, x equals 4. We need to find the coordinates, so let's just sub it into the line. So the y is equal to 3 and the y is equal to 1. Okay, great. Now it says show that the area of the minor segment is pi minus 2. Okay, so if it's tricky, then it's a good idea just to draw a picky. So we've got the centre over here at like 6, 1. Let's draw the circle. It's going to come down under the axis like that. It's going to cut the points at 4, 1, which will be here, and it's also going to cut at 6, 3, which is going to be here, directly above the center. So it's going to look something like that. And the minor segment is obviously this area in here. Okay, so we can see actually that this is going to be a horizontal line radius, and this is going to be a vertical line radius, which means this is going to be a right angle. So what we need to do is work out the area of the sector, and then take away the area of this this yellow triangle. So the area of the sector, well, let's just go straight for the area of the segment. The blue part, sorry, the sector will be a quarter of, so it's well, it's a right angle, so it's a quarter of the circle, multiplied by pi, multiplied by r squared, and the radius we know of that circle is 2. And then we've got to take away the triangle which has radius of both the height and the width. So it will be a half of r times r, which we know is 2 times 2. Okay, so a quarter times by 2 squared is just 1, so that's just pi. And then over here we've got a half of 2 times 2, which is just 2. Brilliant. Well, we're done. Okay, we have a curve and the straight line L have respective equations. Got that one out finally. Show that C and L intersect for all values of C. Wowza. Right, well let's solve them simultaneously, I guess. I'm not sure where this is going to go, but I'm looking forward to the ride. So x plus c squared over 2 is equal to 1. Let's expand out. So let's times by 2 first, just to make it a bit easier. And then let's expand this out. So I'm going to get minus x squared. I'm going to get minus 2xc. And I'm going to get minus c squared. And that's going to equal 2. So I times everything by 2. And I expanded that bracket. And because there's a negative there, all the terms will be negative. Okay, great. This is going to give me 1x squared minus 2xc, and then we're going to get minus c squared and minus 2 as well. So let's just leave it like that actually. That equals 0. Okay, now if they intersect, then it means that the discriminant of this quadratic will be greater than or equal to 1. So let's see what the discriminant gives us. The discriminant will be the b squared minus 4ac. The b term is minus 2c. That comes from this part here, and then minus 4 lots of a, which is 1 because it's just 1x squared, and then let's look at the c term, which are the constant terms, which are minus c squared minus 2. Okay, let's expand. We're going to get 4c squared. We're going to get plus 4c squared. And we're going to get minus 4 times minus 2 is plus 8. So we're going to get a total of 8c squared plus 8, which can be written as 8c squared plus 1. Now this is greater than or equal to, well, this is just greater than 0. It can't even be equal to 0. This is greater than 0 for all c. So it's greater than 0 for all c, as c squared is always greater than or equal to 0. Therefore, c squared plus 1 must always be greater than 0. And therefore, 8c squared plus 1 must always be greater than 0. So that implies that, it's a bit overkill now, but you can say, therefore, the b squared minus the 4ac is always greater than 0, and therefore 2 intersection points occur. Okay, differential equation. First off, we need to separate the variables. So I will write 5 dy is equal to 2y squared minus 7y plus 3 dx. And then let's divide through by 2y squared minus 7y plus 3. Whoops, gotta have a dy there. Is equal to dx. Okay, so this looks like it could be a partial fraction. So let's factorize the bottom. And we will get 2y minus 1 and y minus 3. I think that does the job. Yep. And then we will need to make this into a partial fraction. So 5 over 2y minus 1, 2y minus 3 is equal to a over 2y minus 1 plus b over 2y minus 3. Whoops, sorry. Don't know why I put 2y there, so just 1y. Multiply across, so I get a lots of y minus 3 plus b lots of 2y minus 1. Let's sub in y equals 3, and this will give me 5 is equal to 5b. That's nice and neat, so b equals 1. Great, and then let's sub in y is equal to a half, and this will give me 5 is equal to minus 2.5a, which will give me that a is equal to minus 2. Okay, great, that's all neat and tidy. That means I can now integrate both sides, because what I'm actually integrating now is a is minus 2, so minus 2 over 2y minus 1 plus b is 1, so 1 over y minus 3, and on this side I'm just integrating dx. Okay, so this integrates to minus ln 2y minus 1, because the denominator derivative is the numerator, apart from there's a minus there, so the minus goes outside. This one is a straight ln as well, because the denominator's derivative is the numerator, and dx is just 1 dx that integrates to x plus c. Okay, great. I can write this as a single logarithm over here. So ln of the positive is y minus 3, and the negative is 2y minus 1. That's equal to x plus c, and let's just quickly see what form they want it in. Oh golly gosh, right, they want y to be the subject. Okay, now I can take an e of both sides, and that will give me e to the x plus c, which is the same as e to the x times e to the c, and we can replace e to the c with just, because e to the c is just a constant, it's an unknown arbitrary constant, so we can just replace with a, another unknown arbitrary constant. Okay, great, and I can write that as just a e to the x now. Okay, and let's have a look at the form they want it in. Is that y is the subject. So we just need to do some GCSE maths and just make y the subject. So because it occurs twice, we're going to need to multiply it to the other side and then factorise. So we're going to get 2y a e to the x minus a e to the x. We are going to move all the y's over to the same side. So we're going to get a e to the x minus 3 is equal to 2y a e to the x minus y. Now all the y's on the same side, I can take out a factor, which gives me 2a e to the x minus 1. Then I can divide through. So I'm going to get a e to the x minus 3 over 2a e to the x minus 1. And that's going to equal y. Perfect. Okay, two ways to do this question. First off is let's look at this information here. And that tells me that it's in an arithmetic sequence. So if I write them out in order, like this, then I know that there's going to be a common difference between each of them, which is the same. So let's call it x. I could then write theta as pi over 4 minus x, and I could write phi as pi over 4 plus x. I can then sub in theta and phi into this equation and use a compound angle formula to simplify them down and eventually arrive at a solution. But I'm going to show you a more nifty way of doing it, and that is to first expand these out. And if I were to do that, I would get sine squared theta minus 2 lots of sine theta sine phi plus sine squared phi. And over here I would get cos squared theta plus 2 lots of cos theta cos phi and then finally I would get cos squared phi. Okay, we can then collect up, and we have a sine squared theta plus a cos squared theta, so that's equal to 1. We have a sine squared phi plus a cos squared phi, so that's equal to 1. And then we have 2 lots of cos theta cos phi minus sine theta sine phi. Now hopefully we can spot that this is a compound angle. It's the cosine, because we know that cosine of A plus minus B is equal to cosine A cosine B minus plus sine A sine B. So in this case, this will simplify down to 2 plus 2 lots of, it's going to be a cosine, and because it's a minus there, it's going to swap over to be a plus inside. So cosine of theta plus phi. And we can drop the brackets here, we don't need them. And let's move the 2 up a bit closer. Okay. And now we're going to use our information about the arithmetic progression. So if I make x the subject here of both these equations, I get x is equal to pi over 4 minus theta and this one here I would get x is equal to phi minus pi over 4. And because these are both equal to x, I can set them equal to each other. So pi over 4 minus theta is equal to phi minus pi over 4. And then rearranging this, so I can get theta plus phi on this side and add pi over 4 to that side, so 2 pi's over 4 makes pi over 2. Okay, great. So now I can finish off my expansion here. I can get 2 plus 2 lots of cos, and theta plus phi is pi over 2. And cos of pi over 2 is the same as cos of 90, which is 0. So this just gives me 2. So therefore the constant k is equal to 2. Question 19. Beast question. Show that dy by dx is equal to minus 2 cot cubed t. So dy by dx is equal to dy by dt over dx by dt. Differentiating the y function, I'm going to use the chain rule. So obviously b, the constant, differentiates to 0. 2 comes down to the front. We keep cot t the same, but then we multiply by the derivative of cot t, and the derivative of cot t is minus cosec squared t, and then that's divided by the derivative of x, and a differentiates to 0 because it's constant. Tan t differentiates to sec squared. Okay. Next, let's write these all in terms of sines and coses. So we've got minus 2. Cot is 1 over tan, so that's 1 over sine over cos, so that's cos over sine. So it's cos on top and sine on bottom. Cosec is 1 over sine squared, so that's sine squared on bottom. And sec squared is 1 over cos squared, but we're already on the bottom, so that means it's the same as cos squared on the top. So that's cos squared on the top. So this gives me minus 2 cos cubed t over sine cubed t, which is the same as minus 2 cot cubed t. And then find the Cartesian equation. Okay, I can notice here that I've got y minus b, and I've got here x minus a. So let's use that, and let's say that x minus a is equal to tan t, and let's say that y minus b is equal to cot squared t. Let's square this left one to get x minus a squared is equal to tan squared t. And what's the relationship then between tan squared and cot squared? Well, they're the reciprocal of one another. So this tells me that x minus a squared is equal to the reciprocal of y minus b, because tan squared and cot squared are reciprocals of one another, so therefore x minus a squared and y minus b must be reciprocals of one another. And then we can finish off by multiplying through by that denominator, and we get as required. Okay, I'm going to grab some more space for part B. Okay, part B. This is one of the type of question that if I had in an actual exam, I would probably skip it, because after reading it twice, I'm not 100% sure what to do. So I think in this instance, I would skip it, move on to the next question, and then if I have time at the end, come back to it. Because it's so important, exam technique, in order to complete the questions that you know exactly how to do first, and then come back at the end of the exam to do the questions which you're not 100% sure how to do. So this is me coming back to the question at the end of the exam, and I can see that you've got a straight line which meets the curve, and it has the points y equals 2 and y equals 5 is where it meets. So if I know the y coordinates of the intersections, then I know that they must satisfy the line, so I can work out the x coordinates. So that's what I'm going to do first. So 2 is equal to 6x plus 2, and 5 is equal to 6x plus 2. This gives me that x equals 0, because 6x must equal 0 for 2 to equal 2. And over here we'll get 3 is equal to 6x, which means that x is equal to a half. So the coordinates of intersection are 0, 2, and a half, 5. Okay, so these coordinates must also, these coordinates, we know that they fit on this line, on the straight line, but we also know that they fit on the curve as well, which means I could substitute these coordinates into this curve and they would satisfy this curve. So subbing in the first one into the curve is going to give me 2 minus b for y, and then 0 minus a, so just minus a squared is equal to 1. And subbing in the other point into the curve is going to give me 5 minus b, and x is a half, so a half minus a squared is equal to 1. Okay, this is progress because I've got one equation with 2 unknowns, and I've got a second equation with 2 unknowns, which means I can solve them simultaneously, though it does seem quite tricky. I'm sure there's multiple ways of doing it. This is the way that I would do it in an exam. I would make b the subject here. So multiplying this out is going to give me 2 lots of, that's going to be a squared, and then minus b lots of a squared is equal to 1, and this is going to give me that b a squared is equal to 2a squared minus 1. That works. So b is equal to 2a squared minus 1 over a squared. Okay, then that can go into this one. So I'd get 5 minus 2a squared minus 1 over a squared times by a half minus a squared equals 1. Okay, and then this is just in terms of a, which is great because I want an equation just in terms of a. Okay, let me grab some more space, then we'll solve this. Right, this might not be the most efficient way of solving this question, but in an exam, this is the way that I would go. And do let me know in the comments if you find a better way of doing it. This looks quite nasty, but it's salvageable. Because what I can do is I can multiply by a squared, which would sort out this left bracket, and I can multiply by 2, which would sort out this bracket, but it's squared, so I'd have to multiply it by 2 squared. Because essentially there's 2 brackets like this. There's a half minus a times a half minus a. So I want to times this one by 2 and this one by 2 to make it all integers. So I need to times it by 2 twice. So what I'm going to do is I'm going to multiply through by 4a squared. I'm going to distribute the a squared over here, and I'm going to distribute the 2 squared there. So what will that give me? It will give me 5a squared minus 2a squared, and a minus, so plus 1. Over here, 2 will go into each of these double brackets essentially, so I'd get 1 minus 2a all squared, and that will equal 4a squared. Okay, that's much nicer, much easier to deal with. 5a squared minus 2a squared is 3a squared. So let's just tidy that up. Okay, multiplying out this, first off I will do the square bracket there, so I'm going to get 1 minus 4a plus 4a squared. And then multiplying everything by 3a squared is going to give me 3a squared minus 12a cubed plus 12a to the 4. Multiplying everything by 1 is going to give me plus 1 minus 4a plus 4a squared is equal to 4a squared. We can cancel both of these from both sides. Tidy it up and put it in order. It's going to give me 12a to the 4 minus 12a cubed plus 3a squared minus 4a plus 1 equals 0. Okay, now what we're going to do is we're going to use the fact that we know that a minus 1 is a factor. And we're going to divide this by a minus 1. And hopefully we will get the expression there. Okay, so divide through by a is going to give me 12a cubed, multiply down 12a to the 4 minus 12a cubed. Subtract, that's going to give me 0. Great. So the next line is just going to come down like this. Divide the lead term by a is going to give me 3a. Multiply down, give me 3a squared minus 3a. Subtract, and I'm going to get minus 4 minus minus 3, which is just minus 1, and then the 1 comes down as well. This should be minus 1 up here, minus a plus 1 gives me 0. Perfect. That's a perfect division. So therefore we are safe to say that this is true. Because this is the same as this, and when multiplied by this gives us our expression, which we found from using the information given. So I think that's proven. I'm happy with that. State a possible value for A and a possible value for B. Well, let's look at this straight off the bat. A equals 1 satisfies the equation, so A equals 1. And then we and if we remember from previously, the b value was equal to this, because that's what we replaced the b with. So b is equal to 2, 1 squared minus 1 over 1 squared. So b is equal to 2 minus 1, which is 1 over 1, which is 1. And we are done with that beast question. Okay, the question says we have a curve with this equation, x greater than 0, and it says the equation of the tangent to c at the point where x equals a is 4y is equal to bx minus a, where a and b are non-zero constants. Determine the exact value of a. So the first thing I can see that jumps out is the equation of a tangent. And to work out the equation of a tangent, we first need to find the gradient, which means we're going to need to differentiate this function. This function is a product, has two parts to it. It has x multiplied by the square root of ln x. So we need to split it up and use the product rule in order to differentiate. So first off, I say that u is equal to x and v is equal to ln x to the power of a half, which is the same as square root of ln x. I differentiate each part, so the derivative of u, in this case with respect to x, would just be 1. And then the derivative of v, a bit trickier, but if I've got a bracket like this, I can bring the power down to times by the coefficient. So I get a half right there. Next, I can keep inside the bracket exactly the same, and I drop the power down by 1. And then I multiply by the derivative of the bracket, which in this case is the derivative of ln x is 1 over x. So that's the shorthand way of doing the chain rule. And then my product will be, these two multiplied together, which gives me, well, the x and the 1 over x will cancel. So I just have a half of ln x to the negative 1/2 plus these two multiplied together, and that will just be one lot of ln x to the half. Now it's asked me to work out the tangent at the point x equals a, so I need to find the gradient at x equals a. So dy by dx at x equals a is, we'll just sub a in for x into the gradient function. So I get a half ln of a to the minus a half plus ln of a to the half. Okay, and in order for me to work out a tangent, I need not only the gradient, but I also need an xy point. I have an x point, so I need to find its corresponding y value. So I'll do that by subbing that into the y equation. So y at x equals a is, sub in a for x, so I get a, open brackets, ln of a, and that is the square root, so that's the power of a half as well. Okay, next step is to use my equation of a straight line, which is y minus y1 equals m x minus x1. I'm going to sub in my gradient and I'm going to sub in my xy point. So my y value, which we worked out, was a ln a to the half. My gradient, it's pretty messy, but it was a half ln a to the minus a half plus ln a to the half, and then I need to multiply that by, so I'm going to have that all in brackets like this, and I'm going to multiply that by x minus the x coordinate, which is just a. Okay, great. So my first thought is this is very messy, and what I would like to do is to multiply through completely by ln a to the power of a half. I think that's going to tidy things up massively. So let's do that. Let's multiply through by that. That's going to give me y of ln a to the half. This next term, the ln a to the half times ln a to the half is just going to give me ln a to the 1, so it's just ln a. So this is minus a ln a. And then I will just multiply this ln a to the half by this purple bracket here, which will be enough to do the right hand side. So multiplying through is going to give me, in this first term, it's just going to be a half. And then ln a to the minus a half times ln a to the half is just ln a to the 0, which is just a 1. So it's just a half. And then here we have plus, and the ln a to the half times ln a to the half is just a ln a. Great. And let's bracket that up and then multiply that through by x minus a. We don't need to times it through by the x minus a because we've already multiplied that term through by multiplying through by that purple bracket. Okay. And next we will multiply out these brackets. So this side will stay the same for now. And here we'll get a half x and minus a half a and plus x ln a and minus a ln a. We could do some cancelling. We can cancel these from both sides. And then we can go and look at our what the form that we want it in. So that's 4y. So we've been asked to get it in 4y is equal to bx minus a single a. And what I can notice is that on this side we do have minus a half a. So let's multiply the whole equation by 2. So that will give me this is equal to an x and plus 2x ln a and then minus a. So now we're getting very close to being able to compare coefficients. In fact, we can now compare coefficients. So if we look at what's multiplied by the y, we've got a 2 and we've got a ln a to the half. So therefore 4 must equal 2 ln a to the half, like that. And then if we look at the b as well, we'll have b must be equal to, in brackets, if I take out an x, 1 plus 2 ln a. Okay, so we can solve these two equations to find a and b. So we can divide both sides by 2 first, and then we can square both sides, and then we can take e as the base of both sides to get a. Great. And then over here we can say that b is equal to 1 plus 2 lots of ln e to the 4. So therefore b is equal to 1 plus, that's at 8, so b is equal to 9. And there we have it, our final answers. Okay, here we go. It's a substitution, and we are given the substitution, which is very useful. We are told that root x is equal to tan theta. So the first thing I would do whenever I've got a square root in my substitution, I would always square both sides. Much easier dealing with squares than it is square roots. Okay, now I need to differentiate this. So on the left hand side I'll get dx by d theta. And on the right hand side, well, it might be a bit easier to differentiate it if I write it like this. And I'm going to do the chain rule, but I'm going to do it quickly without too much notation. So the 2 comes down to the front. The bracket stays the same. The power drops down by 1. And then we multiply by the derivative of the bracket. And the derivative of tan theta is sec squared theta, which is given in your formula booklet. So we get 2 lots of tan theta sec squared theta. And then I can get dx as the subject by multiplying both sides by d theta. Okay, great. Now I think we're just about ready to do our substitution. So I'm going to rewrite it as 1 minus x, and x we know is tan squared theta, all over root x, which we know is tan theta, open brackets, x plus 1, which is tan squared theta, plus 1, close brackets, squared, and then we're multiplying that by dx, which we know is 2 lots of tan theta sec squared theta d theta. Okay, great. Now we're going to hope for a fair bit of cancelling here, and the first thing I can spot is that we've got a tan squared plus 1. Now we know one of our identities which links tan squared and sec squared could be quite useful here. Just remind ourselves what that identity is. So if I start off with cos squared plus sine squared equals 1, and if I divide through by cos squared, then I'm going to get a sec squared here, and in doing so I have to divide through here by cos squared as well, and this will give me 1 plus, and that will be a tan squared. So tan squared plus 1 is sec squared. Okay, so I can rewrite that in here as sec squared, and then I can do some cancelling. I've got tan theta on the bottom times by tan here, and I've got a sec squared squared on the bottom, and I've got a sec squared there, so I can cancel one of those, which will cancel the squared there, and that too is just a constant, so that can go outside of my integral sign. So I have 1 minus tan squared theta over sec squared theta d theta, and we can rewrite this as well, sec squared is 1 over cos squared, so if we've got a sec squared on the bottom, it's the same as having a cos squared on the top. So it's 1 minus tan squared theta cos squared theta, and then we can expand out to get a cos squared theta minus and a tan squared times by a cos squared. Well, tan squared is sine squared over cos squared, so that over cos squared will cancel with this cos squared here and just leave me with a sine squared. And hopefully you can spot this trig identity, because cos squared minus sine squared is the same as cos 2 theta. It's a double angle formula for cos. Okay, great. Now that is integratable. And to integrate that, we will, first off, cos integrates up to sine, and then we take the derivative of the input here, which is 2 theta, and the derivative is 2, and we divide by that, so 1 over 2, and we've still got this 2 outside, and then we have to plus c, so our final answer is sine 2 theta plus c. I hope you found that useful. If you did, please do subscribe to the channel, please do like the video, and let me know in the comments what you want to see me do next. I've got lots more A-level content that way. Check it out. Bye for now.